Okay. Um, I think that we can begin because today, as promised, we have some more people to join us and discuss the matters. So yeah, today we have the third meeting of the discussion club, and basically, as usual, we'll be talking about best practices of how to do certain things. And today's topic is virtual environments, conda, and related stuff. Which is basically one of the ways to avoid the dependency hell and make the analysis also more reproducible. Because basically, I remind you what I was talking about in the first lecture, that all of the things which we are discussing in this series are in this or that form related to the idea of reproducible research. And today we have in addition to the usual people, also a couple more folks who are joining us as experts. So first, we have Alona Kizenko. Alona, if you can say a few words about yourself, introduce you, where do you work, and basically what's your area of research now?
Yeah, hi everyone. My name is Alona, and I am currently doing my PhD in Austria in Institute of Science and Technology. And I'm trying to combine bioinformatics and lab work in my PhD. And so I'm mainly working with expression data, with some genomic data. And I would say my feature is that I'm not working with model organisms. I'm working with non-model organisms. And this brings a lot of joy, but also a lot of struggling. Yeah, that's basically it.
Okay, yeah, thank you so much. Yeah, I also think that we have, as usual, Roman Chernacik. Roma, hi. Can you hear us?
Yeah, hi guys.
Great. And I also think that thanks to Roma, we have Konstantin Zaitsev also here. I'm not sure whether he can speak or not, but
I can speak.
Great. Yeah. So then, can you please also say a few words about yourself? Yeah, because
hi everyone. So like I'm a recent employee in JetBrains Research. I've been doing systems biology for quite some time now. Right now I study human aging. And I live in dependency hell. I live there. I strive in dependency hell. And so the topic is very familiar to me, let's say.
Okay, great. Yeah. Thank you. Yeah, I think we also have as usual Gennady Zakharov here. So Gena, are you with us? Okay, it seems that there are some issues with Gena. I hope that he will join us as soon as he can. And also, we are expecting Alex Perdeus to join us shortly. So I hope that he'll also be able to participate in today's discussion. Yeah. Okay. So then I again remind you, and to the people who are new to this meeting, since the first one, we have a tradition to fill out some questionnaires in the and we'll discuss basically the results of what people use. So there is a link to the short Google form in the chat, and also those of you who have registered for the seminars, and I think that's the vast majority of the audience. You have also received the link to the form in advance, so you can find it in your mailbox if you don't see it in the chat for some reason. And we'll turn to discussing the results a little bit later. Yeah, and having said that, I'd like to say a few words about today's topic before we will move on basically to talking about as usual, like best practices and solutions to the problems. So thanks to Costa. Costa said that he lives in dependency hell. I don't know. I think that most of us bioinformaticians do. So that's quite a common thing. Yeah, and I also, while preparing the slides for today, I found a very nice picture about that. So I think that's quite sums it up. Yeah. So basically, again, for those of you who are not that familiar with like routine data analysis in bioinformatics, if there are people like that with us today, the idea of dependency hell is basically the concept of all software which we're using for this or that reason, be it a certain tool or whether you're doing some analysis in Python or R and using some packages for that. Everything has certain dependencies, certain libraries and packages which provide tools and functions which are utilized by other more complex software. And if you are doing it by bioinformatics, and if you have more than one tool, I think, installed in your system, then at a certain time point, you run into the issue of conflicting dependencies. And that's basically absolutely inevitable when you are working again with multiple software, because some software tools may require different versions of the third-party libraries, different versions of the third-party software, and given that you are almost unable to reconcile these conflicts and to run different tools with different dependencies, different requirements on the same system. And this is a very, very bad problem, especially when you are managing complex pipelines, because again, at a certain time point, you have it becomes almost absolutely impossible to manage that. And thanks to the developments of the last several years, I think there are basically two main solutions which have been introduced and are commonly used by people in the community to avoid this, to run each software at least to a certain degree isolated from the other ones. And these two are virtual environments, which is the topic of today's discussion. And the second option, of course, is containerization, which is most commonly implies the usage of Docker, and recently Singularity has been becoming more and more popular as an alternative to Docker. And containerization will basically be the topic of the next discussion. And I think that on this next discussion, we'll also talk about like more hardware-based virtualization and like using the virtual machines a little bit if we have time for that. But today, as I've already said, the main topic is virtual environments. Again, I think that most of you who have worked in bioinformatics for the last several years are more or less familiar with the concept. So basically, a virtual environment is not too isolated of a space, but still, and it is with a somewhat isolated part, basically a shell with paths and all sorts of things set, which encapsulate, at least to a certain degree, certain libraries, software dependencies, packages, and environment variables. And again, the nice thing about that is that you may keep multiple virtual environments on the same system. Each will have its own set of software in it, libraries, packages, etc. The virtual environments are mostly, and most of the people who use this utilize Python-based virtual environments, which can be managed with several software solutions. But this is not the only possible option, and I hope that we'll have enough time today to discuss other alternatives which are not based on Python, but actually based on the actual shell functions, the functions of the terminal itself. Yeah, but again, most of the people who use this usually use the functionalities available in Python. And having said that, I think we can turn our attention to the results of our form. Again, the link is in the chat, so if you are interested, you may submit your response. And basically, yeah, as usual, the first question for us is the level of experience. And also, as usual, we have almost like 50-50 people who have a solid experience in bioinformatics and people who are more of entry level in bioinformatics, and that's perfectly fine and actually what we hope to achieve. And then we have several questions which basically are pertaining to the idea of how we should use and whether we use the environments in general and how we use it. And basically, the first question which I've asked here is, what do people prefer for installation of software and managing basically of software? Because here the three options which are shown and which are used by different people are installing from package repositories in the Unix system itself. Then we have installation from conda, which basically is absolutely related to the idea of installing it into a particular environment, because that's basically how conda works. And the third option here is using the Docker images. And basically, I see that we have a very strong preference from people in the audience, like overwhelmingly, towards using versions from conda if this is available. And virtually no one prefers compiling stuff from sources, which is it's expected, I think, yeah. But I think that there are people who prefer compiling from sources whenever they can. At least I know these people. Unfortunately, they are not with us today, but still. Yeah, and that's, I think this the response to the question, again, the overwhelming preference for conda is a good starting point for today's discussion, because basically, as usual, the first question, which I think is important for these kinds of discussions, is basically what is the motivation to use a particular tool, a particular approach. So in this case, we are talking about virtual envs and conda. And again, my question here to the audience is, so basically, why do you personally prefer using conda, for example, if we compare it to containerization solutions like Docker? Why do you prefer it to installation into the system, basically using systems package managers? So that's my first question. So what's the motivation for you to choose conda and to choose installation into the virtual environments rather than more hardcore things? I think for this case, we may start with Costa for today, because yeah, as a newcomer to the expert panel.
Yeah, first of all, it's not like I always prefer using conda over Docker, but in many cases I do, because for me, I think the clarity of the env files is much cleaner than just like reading the Docker file and then obtaining the image. So like for me, especially when I have like a large pipeline, I will sometimes have, even for each step, I'll have isolated environment with the packages and versions of the packages that I need to run. And for me, these files are just easier to read and easier to kind of manage in the long run. So like, at least like maintaining the env files and environment files like in conda or mamba feels easier for me than maintaining the Docker image that for some reason got obsolete, for example. Yeah. So that's for me. Yeah.
Okay. Yeah, thank you. So let's move on to other people in the panel. So maybe Alona, do you have something to add to this? So what's your motivation to prefer conda? If you do, and if you don't, if you prefer other solutions, then please explain it. That would be very nice.
Yeah, I also chose conda. It's like, first of all, I'm very familiar with it. It was, I think, the main motivation. And also, I would agree with Kostya that sometimes I have environments for a specific analysis, and I can basically do like a quality control on each step. And I think I'm not so familiar with Docker. I used it like once or twice when I ran something on a cluster. And I think it's easier to control the particular steps of the pipeline that you're running if you are running it like kind of manually, if you're manually creating, I don't know, a script to run it. And for me, it's easier to use conda. Yeah, I would say that's the easiest option.
Yeah, that's I think thank you very much for your opinion. I generally tend to agree with the last part of what you've said. So basically about the ease of use, because with containerization, I as I've said, we will turn to discuss it in more detail next time. But basically, both with Docker and Singularity, you have to basically struggle a little bit to run something in Docker. For example, because you have to basically mount all of the stuff, mount all the directories, etc. And this may be a little bit painful, and there are other problems associated with this, which will, I think it's better to leave it for the next discussion. But generally, yeah, well, using something in conda is usually much easier, and for me as well. And that's also the reason for me to also prefer conda versions over the other options. Okay, so we have other people in the expert panel to share their opinions. So for example, Rama, do you have anything else to add to this, or what's your motivation? If you can share.
Yes, I agree with already mentioned motivation, but I suppose maybe I need to revote because I recently switched to Apple Silicon to M2 Mac, and it's very cool. But unfortunately, I didn't manage to install even bad tools using via conda because it has only 4 Intel Max binaries. So maybe I will have to compile everything from sources in near future. And also, as for Docker images, we had some recent bad experience with Mac Silicon because we had a Docker image compiled with Linux, compiled for x64 Intel architecture, and actually we use it for our practice on epigenetics course, and one of students ran it on M2 Apple Silicon chip, and actually some simple operations like trim FASTQ files and do alignment were really very slow. So it took many hours, and there was much slower compared to Intel Max. So in this case, obviously, we need to provide some additional version which is especially for Intel Silicon. So that shouldn't be any emulation mod, but with this new laptops, it could be not as smooth as expected. That's all.
Yeah, thank you. Yeah, well, that's actually I also will support you on the part about the Apple chips. I fortunately I don't use on my own. So basically, I have a Linux based setup, and a standard laptop, which used to be Windows one. Yeah, but I know people who have Apple M1, M2 chips, and they, I think, have also all sorts of trouble with installing different software. And sometimes, unfortunately, it also includes not only like installing from Conda, but also some of the basically using the compiling from sources. Sometimes I think people have ran into some problems with compiling stuff on that. So that's also a little bit of a separate problem, but still, yeah, an architecture level problem, which is also painful.
Yeah. Sorry, maybe to jump into. As for me and my students, I found some things regarding Apple with the BWA, because all my course about the command line tools can be run on Mac with M1 processor, everything except BWA. I don't know what they put in the source code, but it's looks like for now, at least in previous year, it was not able to compile BWA for Mac.
Oh, yeah, that seems bad. Yeah, thank you very much. So yeah, again, thank you for jumping into the discussion. Yeah, and welcome to today's topic. Yeah. So do you have any other like motivation to share, to add anything about the motivation to use Conda and prefer it over other options?
No, what I know that First of all, I try to find and install system from apt-get or other package manager, and if not possible, I'm using mostly Conda. Why I first would like to try apt, because it's much more stable and it's well fit to my system, because Conda packages are somewhat buggy, and I faced several times when Conda package is installed, but in fact it can't run without some system libraries and dependencies. Probably for pandas I faced something like this, and I had to install two versions, one from apt, and after this update from Conda, and only after this update from Conda start working good. And why Conda? Because the Python environments, I haven't used it because I use not only Python code. Most I install via Conda not the Python packages, but some command line utilities. And it's much more easy to install it than using Python virtual environments, because Conda is a more general solution. And as for Docker, just had no time to deal with it. Probably that will be a probable way, but Conda allows me to install a very large set of packages and have the integration, because to Docker you need to bypass the directory when you are working, and I'm constantly forgetting the right command how to launch the Docker containers and to bypass input parameters in it. And with Conda it's much more simple. You just activate the environment and you're ready to use it as in your own unit. So it's the good compromise between the isolation and the simple and smooth usage. I believe something like this.
Okay, yeah, thank you so much. Yeah, having said that, I think we may move on. If there's anyone else who want to add something to what has been said on the motivation about like basically preferring Conda, or there is, I think, one person among the ones who responded who said that he or she prefers Docker. So it would be nice to hear if the person is with us, what is the motivation to prefer Docker over Conda, because that's also an interesting choice. Might be important. Okay, it seems that the person who has answered about Docker is not able to comment on that. Yeah, but I hope that next time we'll have more time to discuss the Docker itself. Okay, let's move on. And yeah, so we've discussed the motivation to choose Conda and basically to deal with virtual environments. And we've also, I think, spoken a little bit about different tools for management of virtual environments. I think I'll switch back to my slides and introduce some of these again to people in the audience who are not that familiar with that in terms of like hands-on experience, and then we'll switch back to our quiz and move on to the discussion. So basically, when we are talking about environments and virtual environments, there are different solutions which can be used for management of virtual environments. So again, I think the concept of virtual environment itself emerged from the Python's virtual env. At least that's my understanding. Maybe I'm incorrect, but generally, yeah, that's why we can say that that's probably like the first option which was there. And the thing is, yeah, as Gennady said, that virtual env, the Python's venv, is basically used generally to manage Python packages, and that's basically why it has I think it's not that extensively used for other purposes. Though sometimes you may see people providing like the end recommending the usage of virtual env for particular software, but usually again for Python-based applications. And naturally, we've already said that we have conda, which is a part of a larger package, which is called Anaconda, and basically conda is included with it. There's also a smaller version, which I think is called mini conda. And conda is basically not simply a thing to manage virtual environments, but also a package manager, and that's what I think many people have already said, that you can not only manage the environments by themselves, but also install software into a particular environment using conda as a package manager. The nice thing about conda is that it will basically do you attempt to resolve conflicts with between different tools if there are different things in the same environment, or something is requiring a particular version which is not available on the system. So it automates a lot of that, and actually does it usually pretty well. But unfortunately, in many cases, we have and that I think is quite common, especially recently, for some reason for me, I'm not sure why, that there are more problems with conda not being able to resolve particular conflicting dependencies, which is much better performed by, for example, Mamba, which is an extension over conda, basically a thing which substitutes in some way conda, which is, but unfortunately, naturally is based on conda, and does package management faster. It does it better in terms of conflict resolution. Yeah, and that's, I think many people in the field are currently preferring Mamba over conda. That's one way to deal with this. And as I also said, that there are other things which are also used to perform management of environments. And these are the environment models in L mode. And I actually am not familiar too much with these things, but I know people who use them. And I hope that we'll be able to hear today about this solution. So basically, both of these are not a Python-based solutions, but basically use the typical shell functions, but allow you to essentially link and store paths to all of the software and executables which are not installed into the system paths, but are available basically as executable binaries in particular folders. So that's a more probably complex solutions for people in terms of managing. So it, in my opinion, requires more effort. But the upside, again, in my view, is that it bypasses Python and basically is a more generic thing. But again, I have few experience with this, and hopefully we'll have someone to comment on that. Yeah, having introduced these solutions, I think we may switch to the results of our questionnaire to see what's the preference of the audience in terms of using different solutions. And naturally, we have conda, which dominates, and like almost everyone who has responded to the question said that they use conda. We have quite many people which said that they've used virtual env for some reasons. And there was also a lot of people who have used Mamba. And yeah, there are some people, one person who has used environment modules. Yeah, and I think that's a good distribution. So we have a natural preference for conda as the basic solution, but we have other options which are used by people. So I think that we may discuss a little bit. So what's the motivation to use something else than conda for basically doing the same things, managing virtual environments. So we have two close competitors, which is virtualenv and Mamba, and I think that we may discuss. So what's the motivation to, for example, choose Mamba over conda? I think I've introduced some motivation a little bit earlier, but still, yeah, if there is anything to add, that would be nice. Yeah. So having said that, I'd like to give floor also to the experts. So let's proceed in the same order. So for example, starting with Costa. So you've mentioned Mamba, I think, in your earlier response. So
yeah, so first of all, I actually used L mod once, I realized. I think in our older cluster at WashU, some of the package versions were isolated via L mod. And you could basically load the tool with the precise version and you'll have all the path loaded. It was kind of cool, especially like if you don't want to install the package yourself and you have admin who actually handles all the packages and all the versioning. This is kind of nice, especially for I don't know, people who just like only start to begin like working on a large cluster, because just like you load the module and you use the package. But yeah, I think I haven't seen it since then though. I used all virtualenv, conda, and Mamba in my life. So like I used virtualenv mostly when I developed some Python packages, and I was mostly developing Python code, like not, let's say, not limited to scientific code. So like mostly like general purpose Python code. Obviously started using conda a lot when I started doing science, doing system biology. And then, yeah, as you mentioned, right now conda is just like suffering every time I have to resolve any dependency tree larger than like 5 packages. I mean, obviously the dependency tree is higher inside of it, especially when you add like bioconda channel and you, for example, you have just like one Lima package from bioconductor. Dependency tree is going to be huge, but still conda just these days is very slow in resolving resolutions and conflicts. It's like very sadly slow. So yeah, I shifted to Mamba quite some time ago. And if you are not using Mamba for some reason instead of conda, consider it. I'm not paid by Mamba, but I'll advertise it everywhere. Yeah, but that's that. I haven't used anything else, I think, in terms of Python code at least. And also I tried to isolate most of the R code so like I usually have R environment, which is like on my laptop, one base environment that I use for like not routine analysis, but like when I look at the data. But then overall, I want to replicate the code, I also isolate R code using Mamba as well. Yeah. So even though it's not a Python code anymore, I still use Mamba. Yeah.
Okay, thank you. Yeah, so does anyone of the experts has anything to add to it?
No, just probably I use on one my conda, and on the second one have a Mamba package manager, and I don't see any big difference between them. Mamba is probably somewhat faster, but in fact they both use the same conda packages systems. So in general, they're the same. It doesn't really matter which engine you use. At least I don't see any big difference between them.
Okay. Yeah, so I think Alona has a hand up and Roma. That's nice.
Yeah, I just wanted to comment a bit on the like the speed. I think using Linux is like is my feeling. I don't know. I don't have any proof, but using Linux, it doesn't really speed up the conda versus the Mamba versus conda. But having the Silicon M1 or M2, it really matters, at least for me. I'm now using Linux, but I was using Mac, and it was really, really slow on Mac using conda. I don't know why, but it happens. So maybe, I don't know if Kostya, you have a Mac, then maybe that's the problem.
No, like I only got Mac recently. I mean, conda is still slow on Mac for sure, but like for me, it was ages even on Linux when conda was very slow. I mean, with some Python packages is usually fine, but when I try to install software for bioconductor, even like a couple of packages, it's just like, no, it just like takes a while. And then it tells you no.
One more thing, when I'm trying to use apt, because they have a much faster package management. And even for conda packages, I don't know, they use some complicated dependency system, and I even don't know what they are recalculating so much. Even when I use the Gentoo, the package management works faster with recalculating dependencies. As for me, I'm using Linux, but yes, conda is still slow.
Yeah, for me, I think I can add just shortly that yes, we've also faced the speed issues on Linux system. I think it was Ubuntu 18, so it's probably partly related to the fact that the system itself was a little bit outdated, but still. Yeah, Roma, please. I think you have head up.
Yeah, from my experience, also conda was very slow, and on Linux machine we do lots of computations on some remote cloud server and remote cluster, and also I want to manage that. So SnakeMake. So last time we discussed different computational pipelines and frameworks, and SnakeMake, it supports conda very smoothly out of the box, and it doesn't support virtual env as far as I know. And if I'm not mistaken, it also supports environment models or maybe LMOD. And maybe 1 or 2 years ago, SnakeMake officially switched from conda support to Mamba support due to these speed limitations.
Okay, yeah, thank you for this addition. Yeah, as far as I know, yeah, SnakeMake for sure allows you to use conda, and conda and Mamba and virtually the same. So basically, it doesn't really matter what package manager you use it, as far as I know. But yeah, with regard to environment models on LMOD, I have never used this, so I don't know whether it has the support. It would be nice to hear again. So we have again one person who answered about having used environment models. We heard something about LMOD from Costa, but if someone can add something about the environment modules LMOD generally, so maybe some of the up and down sides and its integration with the rest of the like bioinformatics environment, it would be nice. So is there anyone here, actually the one who used environment modules in his or her practice? Okay. It seems that
you're
yeah,
someone trolling you in every question.
Okay, probably, yeah. So we have a mysterious person who does like all of these sorts of answers, which are interesting, but unfortunately people don't comment on that. Yeah, that's nice.
Maybe we have like a secret like system administrator who actually compiles stuff from sources and pockets this, puts this into L mode and stuff for people to load on the server.
I think no one actually here answered that.
Oh yeah. So like
No one
compiles
compiles
from
from
sources.
sources.
Yeah. Okay.
Yeah. Well, the thing is, I know that. Well, unfortunately, I think we don't have anyone here today with us from the Institute of Molecular Genetics and Genetic Engineering in Belgrade. Probably due to the fact that there was a Belgrade Bioinformatics conference going on in parallel. Yeah, but yeah, I know that people from there use environment modules. Unfortunately, it seems that they were unable to join us today. This is as far as I know. Maybe I'm wrong. Yeah, I think we Alex Bredos has joined us. Alex.
Yes, I have.
Yeah, nice.
Hi.
Thank you. we were waiting for you. Yeah, so basically we have already discussed a little bit about the general motivation of like basically preferring conda over other solutions when you have different options to install the same software. So we have a very large preference among the audience to use conda over other options like Docker and apt. And we've also discussed a little bit alternatives like virtualenv, Mamba, and environment modules lmod. So if you can comment on any of these questions, yeah, then please do it.
Yeah, so basically we were trying to we work a lot in an interesting place, right? So I work at cellular genetics program, which is basically people doing all the single cell. So a lot of our users do a lot of downstream stuff, and we take care of their upstream stuff, right? So that's a very popular technical request. And conda actually is not super reproducible. So in terms of if you want truly reproducible workflows, we are now definitely shifting towards singularity. So singularity, like Docker, singularity has many important benefits. A, being almost perfectly reproducible. B, it's once you've made it, the image, it's as fast as pretty much having binary installed, right? So you don't need to sort of update things and maintain things in any way. You can go inside using Singularity Console, take a look at everything. You don't need to be root like with Docker. You can build Singularity from Docker from this, like if you have a Docker image, you can build Singularity for yourself and just use it right away. Like it takes 20 minutes usually. Conda is very useful, but we try to encourage people who use like any sort of pipelines to keep Singularity for the few reasons that I basically mentioned. So in terms of reproducibility, just extracting YAML or whatever way would be the way to communicate your conda thing would not be enough for you to reproduce the exact same environment. It's a little mind-boggling that basically I would like, yeah, I would say there's difference like this, because conda you start with your own system pretty much, and Docker you start with whatever stock naked system there is, right? So that's the difference usually, and I think the recipes, the Docker style recipe, tend to be more reproducible. So that's what I have on that. But when you go to downstream stuff, there's usually notebooks, right? That's where having your, like making Singularity image or Docker image for everything you do becomes really unimaginable, because that's where things usually diversify. There aren't really pipelines, more like exploratory data analysis, right? So for that, having an environment, either pip or virtual environment or conda environment, any of those, with all the packages installed, can actually be extremely useful to basically do analysis transfer. So a lot of analysis basically when you do big scale data analysis with lots of notebooks, with lots of people performing them, they are actually very problematic in terms of reproducibility. And the two pain points, A, is basically software versions, package versions, everything, right? And two is basically files you start from, because people tend to start from files in their own file system or whatever, their disk, where they're not accessible to others. So the second would be, I don't know, but the first one is that's what we do right now. We encourage people to basically, if you have, your favorite environments, share your YAML files for the package versions. Again, it's not perfect, but nobody expects people who do data analysis to do hundreds of singularity images for everything they do, because they do try many different software tools, many packages, many different, like that's exploratory analysis, right? So it's kind of wild to even imagine that you would do that. But if you have a consistent environment, you can export that. So that's I guess, a dichotomy that we're settled in right now. It's not a perfect system. There's a lot of complaints because people leave hundreds of notebooks behind them, and people have no idea, where things are. We're working towards making it more transferable, so people don't waste as much time basically looking through their predecessor stuff. At least they'll work out of the box. Yeah, that's what I have, I guess, to say.
Can I quickly ask you about like how reproducible at the worst conda is, especially when you talk about upstream, like just like aligning and quantifying reads? At worst, like what's the worst thing you've seen?
Well, there are some wild things. For example, feature counts basically updated after the 5 years of basically not really doing anything to their software. They've updated the thing, of course, changing the syntax, but they forgot to update the actual label on conda. So you install the latest version, which is actually like when you look under the hood, it's one version before, and the one version before actually breaks the pipeline.
It's insanity.
It is truly maddening. Yeah. So it's basically in that respect, I mean, if you sort of screw up the versioning on your software, that there is no saving against that. No amount of Docker or anything will save you, right? But you can at least go inside. Well, Conda, I guess you can do the same thing. But if you have YAML, that's not the same. Singularity, you can go inside Singularity and run the executable, right? You're like, oh, you're not who you think you are. And well, but with YAML, you'll feel like you literally are insane because it's one version and it's doing what the other version is supposed to be doing. So that's one of the worst recent examples I remember. But yeah, since we do a lot, like the upstream tends to be repetitive. Like we use Star Solo and in some cases Cell Ranger for things. And basically, yeah, you want to have things as reproducible as possible because you run it for many, many people. And yeah, basically that's what like we end up like using Singularity and our own versioning system like on top of that. If you just because okay, Singularity is usually good for like binaries, but you often sometimes have pipelines that also change. So it depends on how much flexibility you need, but yeah.
Yeah, it's nice we've mentioned this because basically, yeah, I think the version thing is a little bit of an important one in terms of conda because yeah, I have included this question, which was at the end of my questionnaire today, about whether the people do pay attention to versions which are installed by conda routinely. I think that it's nice to see that people at least sometimes do, the majority of people, but there are some who don't. And basically, I guess the question here was motivated by our own observation, because we have had a couple of cases when we've installed software from conda, and well, basically it was so for example we had two systems. That was maybe a little bit of background. That was when we were moving from one server to another, and on one server we have installed that I think it was fastp or something like this, and it was the most recent version installed from conda on one system, and then instead of transferring the environment like wholly as a YAML file, because the environment there was a little bit messy, I took basically the command to install the tool and ran the same command on the other system, thinking that would be basically the same, will end up with the same result. And after some while, when again I've installed the tool, I've used it for a little bit, I've observed some differences in terms of the output files. It was not fortunately a difference in terms of the behavior, but basically I think the output reports or something like this. I've noticed this issue, and I've checked this, and I've found out that on the second system, the same command installed a different version from conda. I think that with regard to if you use the systems package managers like apt or something on your operating system, apt usually installs a particular version, and it doesn't basically downgrade the version upon facing some issues with what you have on your system, at least as far as I'm concerned. I'm not sure, maybe I'm wrong on that. Please correct me if I'm wrong. But again, my understanding is that the app tries to install what is marked as basically the latest one. It will throw an error if something goes wrong. Conda doesn't. Conda basically, if you don't specify the version, but you do basically just install the tool and you don't specify the exact version, you may end up with having a different version on your system, which is a little bit weird. Yeah, that's why I've included this question about looking into the versions of software. I have, I think, one example which is also quite weird. When the conda versions are basically just not updated. So we have once used a tool which is called IHS Blast, which is basically a speed up of Blast, and it actually so in conda it's a version which works like nicely and everything is okay. But basically, if you go into the repository and you look into the version which is like the current version of the tool, you'll see it doesn't merely have a different syntax. It basically has a completely different logic. So basically, the whole pipeline, the whole commands of the tool, everything changed completely. The conda package did not get updated at all. And this is also like a case, and I think that there should be other examples like that. So we have example of tools which are not updated on conda, or which have weird issues with the updates.
There is actually an insane issue for whatever is the transposer, like not, what's the very old tool for repeat search in the genome? Repeat masker, right?
Yeah.
Not repeat masker. No, the one from the scratch. If you just have a genome, you want
repeat modeler, I think.
Repeat modeler, I think that's the one, yeah. And then repeat masker can be applied once you have the models, right? So the guy who developed it is an old school guy who hates all the sorts of new things. So there is GitHub, all the open code on the GitHub, and you can use the executable. But someone without his knowledge, without the author's knowledge, made a conda environment which does something absolutely wrong. And he learned about it and he was furious because it just like, you know, it kept failing, and he kept getting questions and issues. And he was like, I didn't make this. This is wrong. Don't use it. You know, so like, and there's no way when you install conda, there's no way to veto, right? To like see if it's authorized. I guess I don't know. Like, so it's one of the wild cases I remember. But in terms of somewhat more general study, I think Nextflow has a paper. Nextflow has a paper in like Nature Biotechnology or something fancy like this. And they have a repo in which they did reproducibility like comparison. So there is a systematic, I don't know, they ran the same pipeline with 300 different environments or something. And then that thing that conda is not fully reproducible is in there quite obviously. Like you get numerically different results in few cases. And I think it can be like kind of used as a very good systematic example, you know, not just like whatever, some people who hate conda or whatever have stock invested in Nextflow. But yeah, there's yeah, that's what I have to
Alex,
say.
can I ask, so this is this paper about comparison different like the replicating the conda environments, so they use the same versions of packages, or how? Oh, what is this?
I think so, yeah. I think it was supposed to be the same, like the same thing you run, right?
So like YAML file, they use the same YAML file to install.
I don't remember how they exactly did it, but basically, if you just Google Nextflow publications, they don't have that many, but there is this like main publication from Nextflow people. And now I think they do develop it as a startup, so don't care much, but they did get 1 or 2 publications in just bioinformatics journals, right? And yeah, there's like either a GitHub repo or something that I've looked for a little bit. Yeah, basically.
Okay.
Yeah, I think Roma has his hand up.
Yeah, I want to add that even with conda, if you have YAML file, you can notice only that packages that you want. So some of your dependencies will be fixed, other will be not fixed, and that's why your environment it's quite clean and easy to read, but it's not reproducible if you don't fix all packages. Or some minor packages. So it's worth the one idea. And I also wanted to add that when we need some reproducibility in our environments, for us worked quite good. So when you have like a Docker container and you have YAML files from your pipeline, and your YAML files are like short and easy to read with only some important packages I mentioned, and then we simply in Docker file we create conda environments using these short YAML files, and as a result we have a convenient way to make a Docker image with all environments that we need, and then it will be fully reproducible when you use these environments, for example, via SnakeMake.
That's nice workaround, I think. Okay, good. Yeah, I think that's an important addition regarding the reproducibility issues. And that's again the motivation why I've included the last question in my form.
There is one raised hand also.
Also raised hand. Okay, yeah, please go on. Yeah, I fortunately I see all of the few people like who are the top 4 of the Zoom. Yeah, so if anyone has his hand raised, I don't see. Yeah, if you have, go on, please go on. Yeah.
Okay. Hello, can you hear me?
Yeah, we hear you. Yeah, please introduce yourself. Yeah.
All right, my name is Hayun Fair, and I'm a bioinformatician. I'm based in Siberia, Russia. And I've got these questions, and the question is about the Nextflow. I kind of tried working with the Nextflow on my conda environment that was installed on my virtual computer, but I was often getting this error message because I was working with a data generated with the Oxford Nanotech technology data. So I had to use to work on an ONT data, which is kind of very, very strange to me, you know, a copy and co, right? But I was getting this error that was indicating something about the thread numbers of my processor. So I was thinking, is there, I mean, what do you think about sorry, can you recommend how you think I can bypass this this issue? Yeah, so that's the question.
Yeah, well, I think here the question is, well, what was the problem? So is it the problem with Nextflow or is the problem with conda? So that's the thing. So do you have the same problem with basically when you use Nextflow without, for example, conda, and it's just on the system itself?
All right, so there are 2 ways in which I tried working with Nextflow. So I tried installing Nextflow straight away on my terminal, my Linux terminal, and it worked pretty well. When I tried installing Nextflow with conda, I was having an error. So I decided to just not create a Nextflow environment with conda and just work straight away on my Linux environment because it tends to like work properly. Then following the tutorial on how to work. Okay, so the pipeline I worked with was metagenomics pipeline with NCORE. Yes, because I could use Epitome lab to work on ONT data relating with metagenomics, relating with metagenomics data, and I could also use NFCore metagenomics pipeline to also work on the ONT data. So I observed that that the Epitome lab could not really work on conda, and like the last speaker spoke, conda, the YAML version is very, very reliable for me. I actually attest to that. But just working straight away on my terminal was very, very interesting. So I tried to work straight away with my Nextflow. I installed on my virtual computer with 4 processors, and my virtual machine with 4 processors, and I was having these thread issues. The minimum thread for my processor was meant to be 6, but I had 4 on my computer. So I was wondering, do I have to upgrade my computer or something of that nature, because I have a 16 gig RAM and quite a strong number of I have quite a good computer. So I was thinking that maybe I have to change my processor, I don't know, to something maybe 12th generation, because I have a 7th generation CPU.
So I can probably comment on that.
Right. Yeah.
So Nextflow's purpose, right, is basically parallelizing things and then also making pipelines with controlled endpoints and like inputs, right? So it's basically, it's something that forces you to carefully log things, control things in terms of where it's like picking up where the previous process ended, and then parallelizing them, and that making that platform independent, right? So it's supposed to work on clusters environments like LSF systems and things like that, or cloud or anything like that. So I think the complaint you were getting, NF core probably has a minimum number of cores, like the pipeline that's committed to NF core has probably 6 set as a minimum recommended number of cores. You have 4, so it just says not enough, right? It doesn't mean that it's truly not enough, but what you can do is basically, on your computer is absolutely no difference between running Xflow or running the same thing and say like conda, as long as you have the right executables or whatever. Epitome is a little bit of a niche thing. It's a cloud product that's kind of abandoned by Nanopore. So I wouldn't stick with Epitome, but there's a lot of open source products that can analyze your Nanopore data. Just find a paper that has a review comparing the methods, 2023, something most up to date. Take a look and pick the one that scores well, conda install that thing, run it on your computer. Nextflow is only valuable at scale for reproducible things and so on, right? If you try in a tool for the first time, you go for the lowest cost solution, something you can get up and running in like 30 minutes. Yeah, you know what I mean? Hopefully it makes sense, but yeah, so Nextflow is good for production, right? If you have production and you're a startup, so you have this server, then server died, you need to move it to AWS, and then, your friend gave you some 6 cores somewhere, you can just do it anywhere. And it's also like actually reproducible, so your pipeline will actually give you the same results every time you do. You can do like conform to that legally if you have legally binding things, whatever. If it's drug design, things can get very serious very quickly. So I don't know, something like that. But yeah, for like trying out things, I'd say this.
Yeah, thank you so much for the response. I have to say that it seems that this question. Yeah, I'm sorry for interrupting. Yeah, it seems that this question is low, but like it is pertinent to the topic we discussed last time. Yeah, when we were talking about pipelining languages. Yeah, it's by itself. Yeah, it seems that it's not the issue of the environments, but the issue with the pipeline in the NF4 repository. Yeah, but yeah, thank you for the question, and thanks Alex for the detailed comment on that. I think that we should move on to one of the last things which I wanted to talk about regarding the environments and content for today. And that was basically the idea of what is the proper strategy to use the environments, create the environments, basically manage the environments for different tools. I had a question here in the forum as well on that, because I know that many people do it differently, and some people tend to be like very attentive and to keep a separate environment for each software tool. Some people do it a little bit differently. They keep an environment for several tools which are a part of a same analysis pipeline. And yes, of course, there are people who just install everything into the base environment and then do install some problematic tools which have conflicts into separate environments, which seems to be the dominant response among the audience. But unfortunately, is a little bit problematic in terms of reproducibility and sharing. And yeah, having said that, I'd like to ask also again the people who are here with us. So what's your preferred strategy, and what do you think is a correct strategy here? So we basically keep a separate end for each tool, or for a set of tools, or in specific cases. So what's your take on that?
So like I think, as I mentioned, I usually have a base environment. So like, yeah, it's like as Alex also mentioned about like doing exploratory data analysis. So like for this case, I usually just have one environment in which I have like all the packages installed. And then if I try to aim to any kind of reproducibility, how would I usually do? It's like I freeze. So like I usually create like almost an empty environment where I only have packages. I specify a couple of versions of couple of key packages that I know that are running currently on my base environment. Then I let it install, then I freeze the environment and I fetch the versions of the frozen environment and put them in the separate env file. Yeah, so something like this. So usually, yeah, one base environment for routine work that's like looking at any kind of data or any kind of package for the first time. And then if you need to do something repeatedly, reproducibly, yeah, just freeze the packages. Yeah, something like this.
Okay, yeah, thank you. So does anyone else has to add something on that? I think Alona mentioned that she uses environments for something closer to like pipelines or like analysis types. Am I correct? And if so, like.
Yeah, I think, like, to be honest, I think there is no correct way to like use environments, because I think it's depends a lot on the purposes, because some people, they do the same thing over and over, like they don't install a lot of new packages, they just update their packages, and I think it's completely fine to have them just in the base and then they use it all the time. But if, like, for example, me, I like to try a lot of new things, a lot of new packages that I find in Conda, and I usually install like the tool in the separate environment, and then if it's comes to the pipeline that I'm using, I just add it to the thing, or like I create a separate one. So I don't have a separate environment for each tool, but I have like evolutionary stuff, I don't know, like expression, this like self-explanatory names for environments. And then I just, install a bunch of things there and use it.
Okay, thank you. Yeah, so that does anyone else from the I think we have a hand up, yeah? Or not?
All right, I wanted to say, hello, can you hear me?
Yeah.
Okay, I wanted to say that one thing I usually do is, for example, let me make an example of conda that releases versions from time to time. I kind of create a new environment to test the product. So I don't know if this is the same for everybody, but I understood that I use a kind of virtual environment that is much more stable and older. I don't really opt for a newer virtual environment, virtual machine. I use a very, very old one. So that correspondingly affects the kind of environment you can, the kind of updated environment you can actually install on it. So let's assume I have a Linux 20.04 LTE, right? And I tend to observe that the newer conda, for example, will always come with an error. So, but that being said, I tend to create a separate environment to test new product, So like Ellen says, in testing something new, I don't install it straight away and onto my more functional environment. Just create something separate to test it. Here, of course, I have a virtual environment, and I also have a Windows Linux environment that has a more updated Linux virtual machine. But still, I still think I'm kind of old school. I depend more on the older Linux. I don't know, but for me, I just think that it's actually wise not to corrupt the older one, because you're going to spend a lot of time trying to set up this environment all over again, and that would be very, very tiring. So that's actually my own input.
Yeah, thank you for the opinion. Yeah, that's a nice idea. Yeah, so basically installing something new in a separate place, not to break and corrupt what you already have there. That's a nice strategy. Yeah, I think I have to if also add a little bit about this matter. So about the installation of specific tools into specific environments. Yeah, so basically we had also a particular issue with the PySam package for Python, which is a thing to work with SAM and BAM files, basically. And again, with different versions of it, it has also a little bit of a different syntax, which is unfortunately quite common for all sorts of packages. Yeah, and we had cases in which we had to isolate specific tools into specific environments, which require different PySam versions. I think we had at a particular time point, we had in a single pipeline 3 different tools. It was something related to structural variant analysis. It basically had 3 different tools, which required 3 different versions of PySam to work. So that's why we had basically to keep a separate env for each of them, and that was a particularly terrible case. Yeah, but in general, I am also in the among the people who tend to use everything in a base environment for exploratory analysis, and then keep separate environments for things which I like to either use myself in the future or share in some form with the other people, because unfortunately, I think that I'm not probably the best person in this regard, because with our recent papers, I think that in some of them we didn't provide the environment YAMLs for the analysis, which can be quite problematic, especially for some tools dependent on conda. Yeah, but lately I think I try to pay more attention to that, especially given all of these sorts of version issues, which are unfortunately popping up at sometimes. Yeah, so that's my take on that. And again, also if anyone else here has anything to add on this issue regarding the proper structure of environments and environment management.
I don't know if it's proper, but I can comment on a couple of things. First of all, don't know, like everybody probably switched to Mamba, but you actually modern conda is not slow, but you have to update the conda, do conda, update conda every time you use it, right? So I do that as like nail trimming. So you do conda, update conda, and you do conda clean minus AY, right? That's like instead of morning coffee. But the other thing that you mentioned, right, in terms of like conflicts, a lot of conda packages are actually stationary binaries, right? So like bad tools, star, bunch of like bow tie. So all of those can obviously go into base environment and they will not interfere with anything. But whenever I see like Perl, Python, or any packages installed, that goes into separate environment, right? That's my rule. You just, you know, if you just install it, if you read it, it's like, yep, you're going in a cage. You'll not be allowed to like.
Why not the garbage bin right away?
Well, you know, Yura actually mentioned PySum. When I worked in genomics, I once counted how many different BLAST versions I had installed, like instances. I had 13 BLAST instances in. So yeah.
Okay, yeah, the 13 blast, that's a good thing, yeah. But it got go in a cage, yeah, that's also quite familiar case. Yeah. Yeah, I think that Alex mentioned that one question which I also wanted to ask people. Maybe someone has anything to comment on that. Yeah. So if because sometimes, yeah, we have Mamba helps a little at least, and sometimes a lot with conflict resolution, but still in some cases there are issues with the installation of something from conda in terms of conflicts which cannot be resolved properly. And sometimes, unfortunately, conda does weird things when it basically throws strange errors like conflicting dependencies with versions which are actually the requirements which are actually satisfied, but it doesn't for some reason understand that. I don't know. Yeah, I think I have resolved this with updating conda once. Yeah, and that's my way to do this. So when the conflicts become too painful, I usually try to update everything and hope that the issue will get fixed. But if anyone else has like any other strategies of what you basically do if you face the conflicts which cannot be resolved, so basically, do you have like any pipeline to do this, or do you opt for like basically compiling from sources right away? So what's your idea on that? So if someone else has some like favorite way of dealing with strange conflicts in conda or irresolvable conflicts in conda, then you can put
yeah, so like especially recently when we like moved to the new silicons, Mach wise, like a lot of conda dependencies and versions just like broken or non-existent basically. So like my favorite way is just like go to server with Linux and work there. I consider compiling some of the things because I use them quite often, and not having them around is quite troublesome. And I actually compiled some just basically for my like base environment that I use like routinely. But like if I want to do something reproducibly right now on my laptop, I'll probably like go with the Singularity or something, because this will be just like much easier to actually work with. But like, I don't know, like Roma also mentioned that like recent silicon chips have problems with Docker as well. So I think my way is just like to connect to the server with the Linux and work there forever. Yeah.
It's good when
You can also wait a bit. Oh, sorry.
Yeah, please.
Yeah. So like waiting is a good
Wait,
strategy. Yeah. That's what I'm doing right now. So like I'm kind of upset about some dependencies. Like I don't want to compile them. I'll just wait. They'll come up with it. It's fine.
That's a nice strategy, I think. Yeah. The only problem is that sometimes you don't have enough time to wait. Yeah, but generally, yeah. Okay, good. So I think that having said that, we may conclude today's talk if there are nothing to no one has anything to add to this. Yeah, next time we are my plan was that next time we were going to be discussing the containerization, but I will think about it a little bit because I think we've touched upon the issue today with Alex commenting on singularity versus Docker choice. And we've seen that a lot of people prefer, like, people do not use Docker that often, as far as I can see from today's quiz. Yeah. Yeah, so I'll think a little bit whether we should dedicate a separate seminar to discussion of Docker and Singularity next time, or we may proceed to other points in the program of the session and turn to Docker and other issues we weren't able to discuss closer to the end of the session. So I think I have to think about this a little bit. Yeah, but according to the plan, we have Docker next time. If not, then we may have markdowns and notebooks as a different topic. Yeah, I will inform everyone as usually in the mail, and of course everything will be updated on the website. Thanks to everyone who have participated in the discussion. Thanks to the experts. It was very nice to see more people today, and very active discussion. That was really fascinating. Thanks to those of you who have commented from the audience. That's also very nice and facilitates our discussion on the matters. Yeah, so thanks to everyone who has joined. And yeah, if there are no questions and nothing to add, then we may conclude for today, and see everyone next time.
Thanks. Bye-bye.
Thanks. Bye, everybody.
Thank you. Bye.
Yeah, thank you, everybody. Bye-bye.
Yeah, goodbye.